For my culture assignment, I am going to be taking the movie The Vow with Rachel McAdams and Channing Tatum, and I'm going to interpret the opening car crash scene. And right now I'm going to show you the car crash scene that I am going to be interpreting.
Moments of impact.
For the scene that you just saw, I'm just going to be discussing the impulse of McAdams and converting it into acceleration to determine if the car crash would have given her a concussion to lead to the brain damage that she had in the movie and the loss of memory. In order for her to get the concussion, her acceleration had to have been greater than 1,000 meters per second squared, which can be found in our notes from Dr. Holcomb's lectures. In order to do the calculations, I estimated a few values. I'm saying that the truck mass is 5,000 kilograms, the car's mass is 1,000 kilograms, the truck's initial velocity is going to be 20 meters per second, and the mass of McAdams is going to be 60 kilograms. Now what you can do is you take the impulse equation, which is the average force times the time of contact, and this is the equation, this is the part of the equation that we're going to be using to convert, and we're going to take this to get the change in momentum, and in order to get the change in momentum we have to get the change in velocity. To get the change in velocity, we're going to do, so the velocity of the car is equal to the mass of the truck times the velocity of the truck, and we're going to divide that by the mass of the truck plus the mass of the car, and this will give us the velocity of the car. So here what I did, I took the equation for the velocity of the car and I plugged in all the numbers. So we have 5,000 times 20 meters per second divided by the mass of the truck and the car, which is 5,000 kilograms plus 1,000 kilograms to equal the car's velocity. And when you calculated it, I got 16.667 meters per second. And from this, you can use this number to get the momentum of McAdams, which P is equal to the mass of the person, times the velocity of the car. So here we have the velocity of the car, which is 16.6667, and we're going to take that to momentum. So I have P is equal to the mass of the person times the velocity of the car. When you plug in the values, 60 kilograms for the mass of the person and 16.6667 meters per second for the velocity of the car, you get 1,000.02 kilograms per meter kilograms meters per second. Now this is also equal, the momentum is also equal to impulse, which is also equal to the average force. So now what we can do a lot of conversions because force is equal to mass times acceleration. We can take this equation and convert it to find the acceleration of McAdams going through the window. So this is our force equation of mass times acceleration. Force can also be calculated as the mass of a person times velocity of car over time. So if you set these two equations equal to each other, what's going to happen is the mass is going to cancel out for both of the person, and you're going to be left with acceleration is equal to the velocity of the car over the change in time. And for our project, we're going to be taking this acceleration, and that's where we're going to figure out if she was able to get a concussion or not. Okay, so we have our acceleration equals the velocity of the car over time, and this time is the time of contact, so we're estimating that value to be 0.03 seconds. So you take the velocity of the car, 16.6667, and you divide that by the time of contact, which is 0.03 seconds, and you're going to get 555.5667 meters per second squared. Now, in order for McAdams to have a concussion, that the acceleration had to equal 1,000 meters per second squared. Our number is less than that, so she was not able to get a concussion from this car accident. So after all the calculations, we concluded that McAdams could not have received the brain injury that she did during the movie and the car crash because her acceleration was less than 1,000 meters per second squared. All of the values that were used were estimated, so that could have been a reason why that we came up with a lower number. And in order for McAdams to have gotten the concussion, the truck would have had to weigh more and would have had to have a higher velocity when it hit the car than what we assumed, or what I assumed. And that is how I calculated it, and that's for the movie Val, for the car crash scene with McAdams and Tatum that was released in 2012.